What is up? My name is Matt, working for Cinematography Database, and in this video we're going to be breaking down the different components for PC hardware that you would need to be using Redshift render. This information is available on other places on the internet, but I thought I'd make a video about it because when I was searching for this information, I couldn't find it on YouTube. So let's get right into this. Okay, so once again, this is the PC hardware guide for Redshift 3D late 2017, because this information is subject to change as things develop and new hardware comes out. And this is specifically going to be for Cinema 4D, though I think it applies for Maya and Houdini. I'm a Cinema 4D user, but I think this should work out for everybody. So first of all, what is this? This is a guide that's gathering all the relevant information about hardware and Redshift render and just trying to put it into one place so that we can best utilize Redshift's powerful GPU render sexiness and figure out what hardware we need to do that. The second point here is that isn't this information already on the forum? Yes, I'm actually getting most of this information from the forum, but also from an NVIDIA and Redshift and someone else workshop that I took today, webinar. Anyway, this information's out there on the internet, but I thought I would put it all into one place. But if you want to hear it straight from Redshift or from other people in the community, you can head over to the redshift3d.com forum as well. Moving right along to the probably most important and interesting part about this is we're going to compare all of the modern NVIDIA GPUs as of late 2017 and talk about which ones are better for Redshift and why. So in the top here, we have the three in gray, and these are what we're calling the professional grade GPUs. And they are the Quadro GP100, the Quadro P6000, and the Titan XP second generation. I'm just calling it the second generation. There's kind of like a confusion about the naming system, but anyway, you can see that the prices of these are very high here. We're going to look at 7,000, 5,000, and 1,200. It's kind of crazy, especially for the top ones, but we'll talk about why these cards are so expensive. What they have in common right now is that they are all Pascal. So they have that here. And the most expensive card and the newest, has 16 gigabytes of video RAM. The next one, the P6000, has 24, and then the Titan XP, which there's a Star Wars version of, which I've considered looking into, that has 12 gigabytes of video RAM, and we'll talk about that more and what that means in the next slides. Next, we're going to be looking at the CUDA cores. We can see that they're pretty much all the same, and then the power draw also pretty much the same. So we're looking at this, and it's like, why does the card, the P6000, with the most video RAM, why is that less than the GP100? And we'll look at that in the next slide as well. But just so that you know, this is the current 2017 lineup of the professional high-end NVIDIA Quadro and Titan Pascal GPUs. Next, moving on, we have down here, we have the gaming cards. And these are like the consumer cards that are out there for people who are mostly playing video games or doing VR content development and or just viewing. But these actually work incredibly well for Redshift, and these are what I'm using as well. So we're going to start at the top here. We have the GeForce GTX1080ti. These are all Pascal except for the bottom one here. This one has the most video RAM, and it also has the most CUDA cores. And as we go down the list, the price decreases and the number of the amount of video RAM decreases and the amount of CUDA core decreases, as well as does the power supply. So this is pretty much a linear drop here. I mean, these three here, the 1080, the 1070 Ti, and the 1070 have all the same amount of video RAM, but the amount of CUDA cores is changing. So you're essentially paying for more CUDA cores as you go from 1070 to 1080. And then if you want the top of the consumer cards, you get the 1080 Ti. It has the most video RAM by quite a bit, 11 gigabytes, and it has the most CUDA cores, and it also requires the most power. For your information, I have a PC that has two of these 1080 Ti. So that's the breakdown of the cards, and then we'll talk a little bit now about the differences between them. So I'm relatively new to the NVIDIA world. I've been living in the Mac world for quite a bit, but because of Redshift, I have completely moved to PC and I built my own computer. And the first question that came up to me that was kind of hard to find the answer to, in my opinion, was what is the difference between a professional card and a gaming card? Obviously, the price is ridiculously different, and that's pretty obvious, but what are the real tangible differences between these kind of cards? So to start, if you want a lot of VRAM or GPU RAM, or however you want to think about that, you basically need to get one of these professional cards, because if we go back to this slide, you can see that the Quadro GP100 has 16 gigabytes, and the P6000 has 24 gigabytes, whereas all these other ones have basically 11. So you're basically doubling up to get the Quadro P6000. So for you, if you need to load really big scenes, and we're talking about like, especially I think for Houdini people doing open VFB, is that what it's called? I don't use that stuff at all, but the stuff that are doing like explosions and smoke simulations, that sort of stuff, that stuff gets really big and it doesn't work with the out-of-core architecture. You need to load those gigantic scenes into the GPUs. And if your scene is, you know, over like, what is it? They're saying that 30 million polygons, I wrote it down here, is about a gigabyte. So if you're saying like 150 million polygons, if it's more than that, you're going to need to go to one of these Quadro cards for like max performance. So basically VRAM in the professional cards, they're just really big, 16 gigabytes, 24 gigabytes. So if you have huge scenes and you want them to be really, really fast at rendering and computing, you're going to need to go with these Quadro cards. Next is the Tesla computer cluster, which I never heard of before. This is the TCC, and apparently the Windows display drivers, I'm just reading this basically, it basically slows down the communication between the CPU and the GPU. So it just makes the GPU's performance less than their full capacity, I guess, compared to Linux. But if you're using the professional cards like the GP100, I think the Titan XP second generation as well, and the P6000, if you're using any of these really high-end workstation cards, the professional cards, they have something called Tesla Compute Cluster, which I spelled wrong here, TCC basically, and this allows you to bypass the WDDM, and it's much, much faster. You get better performance out of your graphics card. So that's something that I didn't know. I read that in their white papers. And then this isn't like so much outlined by Redshift, but I've heard this from Radeon and from other people, is that one, these Pro cards are designed and warranted at like, you know, $6,000 a card and more. They have a warranty to be able to basically put them in a workstation and just have them render nonstop for like weeks or months or maybe even years. I don't know if years really makes sense, but they're designed to be run for a very long time and not overheat, and that's a big deal. I think someone said that the P100, or I get these names wrong, the GP100 can actually run at a more efficient, it's more efficient at using energy and doing the computations than, say, the 1080 Ti or something like that, because they're just designed to be used much longer. And actually, I believe if we go back to the slide, if you look at it, the most expensive card with a good amount of RAM and a lot of CUDA cores actually runs at less power than even the 1080 Ti. So it's a more efficient card. And I think in the end, that basically means that it can run longer and it's not going to overheat. Actually, I heard heat dissipation is something that the new very, very high-end card does very, very well. Because especially if you have like 2 or 3 of them together, they're going to make a lot of heat normally. And so being more efficient with energy and heat management, that's going to make a big deal for a very high-end card that's rendering for like 10 weeks straight or something like that. Next is better support. Again, this is not like official, but I've heard this from the Pro cards, is that if you're spending like $5,000 or $7,000 per card, and maybe you're putting this in like 20 workstations because you're like that kind of a company, at that scale you have better customer support than you would get from like a gaming card that's meant for like one person to be able to play like Overwatch or something like that. These are very expensive cards and you're going to get better support because you're paying so much money. I've just heard that before. Something that's kind of new here that I believe is only with the GP100 right now, I just saw this on a webinar I was on, is that they have something called NVLink, which is new, and it allows you to combine the VRAM together so that you can have 2 P100s essentially that have 16 gigabytes and combine them together and get 32 and actually be able to load that big of a scene into that GPU combination together. So that's pretty cool. I would also say that, I think I said this in the other slide, but right now you cannot actually combine gaming cards using SLI. That doesn't work with Redshift, but potentially with NVLink you can combine the GPUs together. But as of right now, Redshift says that they are not supporting that because there's only like a couple cards or one card essentially that allows for this. As it becomes more common in the industry, they said that they'd think about, you know, supporting this and putting the R&D time and the money into it. So that's pretty cool for the people that are buying $7,000 GPUs. If you get 2 $7,000 GPUs, you can put them together and you can load massive, massive scenes into that. So that's pretty cool. And that's the main difference between professional and gaming. You're going to load bigger scenes. It's going to be faster, especially on Windows 10. You're going to get better performance out of the cards, and you get to run them longer, better customer support, and maybe in the very, I don't know, maybe in the future, you're going to be able to combine them together using NVLink. So I feel pretty safe saying that most people are probably not going to get these $7,000 or $5,000 professional Quadro cards. Maybe if you're working at a really high-end company or doing some like really, really high-end long renders or something like that, that's going to be a good option for you. But most people are going to probably stick with the GTX gaming card. So in this slide, we're going to talk about some of the differences between them. It's pretty obvious, but I thought I'd just go down the list here. The first one is again VRAM. So the reason you're going to go with, say, the 1080 Ti over any of these other cards is because it has 11 gigabytes of RAM, and all the rest of them have 8 gigabytes. So if you're concerned about loading bigger scenes, the 1080 Ti is the way to go, and that's why I have 2 of them. It's good to note that Redshift, unlike some other GPU renderers, has something called out-of-core architecture. So if your scene is bigger than 11 gigabytes, but you only have an 11 gigabyte GPU, it can actually process some of the geometry and the textures. I think it loads them into RAM and traditional storage that's not on the GPU, and so you can load bigger scenes, but you can't load volumetric explosions and stuff like that out of Houdini. But you can load these bigger scenes because it's going to put them into RAM and into the disk, perhaps. I'm not really sure if that's where it goes. But it's, of course, at a hit to the performance because the GPU is really, really fast and this other stuff is less fast. But it is possible, and I wanted to put that out there for people that are considering getting a couple 8 gigabyte GPUs. You can still load bigger scenes. You can just load even bigger scenes with the 11 gigabyte card. Next is CUDA cores, which is pretty obvious. So the CUDA cores, I believe, are kind of like the main thing that speeds up the render. So the more CUDA cores you have, the faster the render goes. And I said it before, but although you can put these cards into SLI, my two 1080 Ti's are in SLI, I have them disabled when I'm doing anything with photogrammetry or with Redshift because SLI doesn't work. It's buggier, I think. It's more prone to crashing, and it actually makes the render slower than if you made it not SLI. So that's important to look there. And if we go back to the slide here, you're basically just increasing how many CUDA cores you get the more you spend. And I think you really get the best value on the 1080 Ti, but I'm just probably trying to convince myself that because that's what I got here. The last thing I wanted to mention that I learned about in the presentation today from NVIDIA was that there's different ways of cooling these cards, which I did not realize when I bought mine. And they said that the best way to do it is with the reference kind of cards. And those are the ones where like the fan is like, it looks like it's kind of like contained with it. I would show graphics, but I try not to show stuff that isn't stuff that I either took as a photograph or filmed myself. And I don't have any cards here. And I don't want to flip to pictures. I just don't do that on this channel. But essentially my card is more of like what they call like the consumer or enthusiast cards that have 2 fans on the bottom. Apparently those aren't very good for sustained use. They're semi-fragile, they can break apparently, and they also don't stack very well. So I have 2 in mine, and from what I've heard, it's actually kind of hard to fit all 4 and have the heat actually still dissipate. Apparently the reference cards are a little bit better for that. So I think that's like the 1080 Ti Founders card, etc. And it's kind of like this kind of hybrid combination between liquid and fan cooling. And they are more expensive, so which kind of explains why I didn't get those. And I only have 2 in my machine, so it's not as big a deal. But if you're going to put 4 in there, you should probably go with the reference cards. At least that's what they're telling me. So that was the fun part, talking about the different graphics cards and cores and video memory, etc. And what's pretty cool about Redshift, which I'm pretty happy about, is that you can combine the Quadros with the GTX cards. That's really awesome, and I believe you're allowed to use cards with different amounts of memory and cores and different architectures. That's very cool. And if you have like a mishmash of older GPUs, you can still just throw them in your machine and get some sort of performance increase. If you want to figure out like the perfect min-maxing of the GPU cards you have and should buy, etc., you should probably go to the Redshift forum. I don't really know that stuff all that well, but I wanted to just note here that you could combine them all, and that's pretty cool. Moving on to the motherboard and CPU. With the motherboard, you want to have as many PCI E3 X16 slots as possible. I think my X399 Mobu has a good amount of them. I don't know if I have 4 of them. They say like, if you want to put 4 GPUs in them, you're going to want something like, 4 of these 16 speed ones. But they're also saying that if you have a mixture of the 16 and the 8, it's not a deal breaker, but it's not necessarily as fast as it possibly could be. You're kind of throttling the speed of some of your GPUs if you have 4 and 2 of them are on, X8 slots. A little bit slower, but it's not like a massive decrease they're saying. But in general, get a motherboard with as many PCI 3 X16 slots as possible. And the CPU is kind of the same thing, but this is kind of true for a lot of 3D stuff, is that they want to prioritize getting a 3.5 gigahertz plus clock speed over having more cores. And I got a Threadripper 1950X because I'm doing a lot of CPU core intensive rendering as well, using physical render and some other stuff. So I actually went for one that's only 3.4 gigahertz, but it has a whole lot of cores in it. and it's been working out fine, but they're saying that in general, if you want to power 4 GPUs or less here, you want to go with a high-end Core i7. And if you're going to power more than 4 GPUs, because you're crazy, you're going to want a dual Xeon setup for the CPU and the motherboard, of course, as well. So you need to have enough PCI lanes in your CPU to power the GPUs, and then on the motherboard, you need to have enough PCI 3 slots. And I don't know enough about the different models of the CPUs and motherboards to give examples, but you guys probably do. But these are the specs you need for Redshift. Moving on to power, cooling, memory, and disk. This stuff's all pretty straightforward, but something to note is that 4 graphics cards, if that's what you're going to be putting in them, like 4 1080 Ti's, for example, which is what I was kind of planning on doing eventually, each one of those, let's go back to the slide actually, the higher end cards all pull 250 watts. So 4 of them is 1,000 watts, which is a lot of power. So you're going to want a power supply that's 1,200 watts to 1,600 watts, which I have a 1,600 watt power supply, which everyone told me I was crazy for getting a power supply so big. Now I feel pretty legitimate because I do intend to put more hard drives and more GPUs into this thing, and I just don't want to be limited by the PSU. And if you're going to put 4 GPUs in it, you need a lot of power. As far as cooling, I think this goes without saying. You need to keep the CPU cool, and you're going to need to keep these 4 GPUs or however many GPUs you have. You need to keep them cool. So when you're putting it together, you want to be considerate about how tightly the GPUs are stacked and if you're cooling them properly, because if they get too hot, they slow down, they throttle themselves to keep the temperatures down. So you want to keep it cool, and you want to have a lot of power at the same time. Moving next to RAM, this is directly from Redshift. They said that you want to have double the amount of RAM as your biggest GPU has video RAM. So, you know, if you have, like what I have, 2 11 gigabyte 1080 Ti's, you're going to want 22 gigabytes, or you're basically just going to want 32. And I got 64 to be safe. And I'm doing photogrammetry, which needs as much RAM as you can possibly get. So I think in general, it's safe to say you need 32 gigabytes of RAM just to be safe. And for, like, you know, Photoshop and everything else and Resolve, more RAM and fast RAM, the better. And the last thing here is the disk. I think we all probably know this. Go with SSDs. It's going to need to read the texture caches off of it. It extracts the scene data off of the disk. Just use the fastest disk you can get. And I have a 1 terabyte, and I don't see my scenes needing to be being any bigger than that. And I could probably use that for quite a while, even though I have a couple externals to hide most of the data on. And moving on to the last slide here, we're PC or Mac and Linux and Windows. So we'll just go through this really quickly. So most of the people using my plugin for Cinema 4D are Mac users, and that's kind of a sad day because R3 of Cinema Designer is going to be taking advantage of Redshift. That's why I'm doing so much content about Redshift and doing so much research into it. And if you want to use Redshift and you're on a Mac, well, Redshift only works with NVIDIA CUDA GPUs. It doesn't use OpenCL, and it's probably not going to for quite a while. So you're going to need either maybe some of the older Macs had NVIDIA stuff, like my old MacBook Pro has an NVIDIA card. I don't know if that's actually would work. It seems like it's pretty old. You're going to need to use an external GPU. And there is someone who's in the beta of Cinema Designer R3 for Redshift, and he has reported that his external GPU with a Titan XP on a Mac computer using Redshift, using the beta, it worked. So it's confirmed to work. You can run Redshift on a Mac with an external GPU. Maybe I'll do a video on that, but someone who's using my software has confirmed that it works for them. Right now, there's a lot of caveats to it. It's not really fully supported yet by OS X. I think High Sierra is going to support it in the future. And hopefully, over time, it's going to get better. And you can just plug in your eGPUs through your USB 3 or whatever, Thunderbolt 3 connection. And you're going to be able to use Redshift even if you're on a Mac. There's obviously going to be performance hits to that. That same GPU running on Windows or Linux would be much faster. But hey, you're still going to get faster speeds than you'd probably get from like V-Ray or Arnold or a CPU renderer. Maybe. That's probably worth testing, actually. Moving on to Windows. There's like apparently some debate between Windows 7 and Windows 10. I can't see using Windows 7. I just feel like that's going to just not be supported by like all the Adobe programs and Cinema 4D eventually or something like that. So I'm just using Windows 10, but apparently Windows 10 uses 10% of the GPU. It just has that much overhead reserved so it doesn't crash or something like that. Not exactly sure. We talked about it before with the WDDM that slows the communication between the GPU and the CPU, but if you're using the TCC cards, the Titan, the GP100, the P6000, that bypasses that and it gets much faster again. And I would say that Windows is probably the most stable and the most common computer you're going to see for Redshift. That's what I have, and that's what most of the people who I've talked to, were they like Puget Systems or Box, or they built their own. Windows 10 it seems like the way to go, at least right now. For people that want to use Linux, it's super fast. Well, so I put that I am not personally a Houdini user at the moment, but I've heard that Houdini runs 30% or more faster on Linux, and that's enough reason to do that. If you have a dedicated Houdini machine or your dedicated like render GPU slave system, apparently Linux is much faster, and it doesn't have the Windows DDM system, so the GPU performance on Linux is faster. Like apparently if you have like 1080 Ti's or 1070s that don't have the TCC, if you put those same cards on a Linux machine, they're going to be faster. So that wraps it up for this video. If you liked the video, give it a like and subscribe to the channel. I'm going to be doing a lot more content on Cinema 4D using my products and other general products for Cinema 4D, and I'm going to be using Redshift as well as physical render. Going to be a lot of content on both of those things on this channel. If you have any questions about Redshift and the hardware, you should probably go to the Redshift 3D forum, which I will link to down below. They have a hardware section. A lot smarter people are there. And I just wanted to make this video and put it out there and get the basic information out there. And with this, if you have any more real questions that you kind of have some jumping off point to go through. Again, this video didn't exist on YouTube when I went to look for it. So hopefully this is helping someone out there. Until next time, I will see you guys later. Cheers.